Hi friends, welcome back to Sea Level Physics. My name is Srinivas, known to be BS Rao. I requesting all the audience to please subscribe channel Sea Level Physics, which is very useful to all the students right from the foundation level up to IIT JEE, including NEET aspirants. Okay, let us discuss special cases of parallelogram of addition. Special cases. In the previous class, we have come across to find resultant of two vectors by constructing one parallelogram. Okay, here p bar and q bar are given vectors which are to be added. Okay, what is the angle between these two parent vectors? Theta. Theta is the angle between p bar and q bar. Now these two are taken as the adjacent sides of parallelogram drawn from the common point O. Okay, from the same common point, diagonal passing through the common point gives the resultant of p bar and q bar. P bar and q bar. Now r bar equal to p bar plus q bar, that is indicated by the diagonal of the parallelogram drawn from the common point O. Okay. Now angle made by r bar with p bar is alpha. Angle made by r bar with q bar is beta. Now alpha plus beta equal to theta. Alpha plus beta equal to theta here. Alright. Now if this is q bar, this one also q bar. If this is q, this is also q. Now here I extended one normal from point C on to P bar like that to get right angle triangle ADC as shown. Now as this angle is theta, here this is also theta. Now with respect to this side, this is opposite side. This is opposite. This is adjacent. So therefore opposite side means as it is q, this is q sin theta. As this is q cos theta. So q cos theta, q sin theta. CD is q sin theta, AD is q cos theta. Okay. Now from the previous class, we have come across the magnitude of resultant is equal to root over p square plus q square plus 2pq cos theta. That is number 1. From this right angle triangle ODC, tan alpha equal to opposite side CD by adjacent side OD, that is q sin theta by p plus q cos theta. So tan alpha equal to q sin theta by p plus q cos theta. 4 over alpha plus beta equal to theta. Here theta is the angle between parent vectors p bar and q bar. Alpha is angle made by r bar with p bar and beta is angle made by r bar with q bar. Right? As I told you in the previous lecture, resultant always close to that vector having greater magnitude. Greater magnitude. See, r bar equal to p bar plus q bar. In that case, if mod p bar is greater than mod q bar, that is mod p bar is greater than mod q bar, means resultant close to p bar, implies that alpha is less than beta. Alpha is less than beta. If at all p is less than q, that is the magnitude of p bar is less than that of q bar, implies that magnitude of p is less than q means q is greater than that of p. In this case, resultant lies close to q bar, implies that beta is less than alpha. Beta is less than alpha. Okay. In the third case, if p equal to q, that is mod p bar equal to mod q bar, then resultant, that is diagonal, bisects p bar and q bar. Means it passes midway of p bar and q bar. Implies that alpha equal to beta equal to theta by 2. Why? Because if p equal to q, that is alpha equal to beta. Why? Because resultant, that is diagonal, will pass midway of p bar and q bar. That is p equal to q implies alpha equal to beta. From this relation, third implies alpha equal to beta, implies that alpha plus alpha, that is 2 alpha equal to theta. Otherwise, alpha equal to beta no, implies beta plus beta, that is 2 beta equal to theta. That is 2 alpha equal to 2 beta equal to theta, implies alpha equal to beta equal to theta by 2, provided both parent vectors are of same magnitude. In that case, resultant passes midway of p bar and q bar. Midway of p bar and q bar. So what is the inference from this discussion? Means resultant always close to that parent vector which is having greater magnitude. Right? Coming to special cases. Special cases in the sense we have to add given vectors by changing angle between them, right from 0 to 180 degrees. So first case 1. case 1. If theta equal to 0. What is theta here? Angle between parent vectors which are to be added. Okay, if theta equal to 0 degrees, that is here P bar, this is what P bar, this is what Q bar. P bar, Q bar are parallel to each other. Parallel to each other means here check. Substitute theta as 0 degrees. That is one implies R equal to root over P square plus Q square plus 2PQ cos theta means 0 degrees. Means given parent vectors are parallel to each other. That is inclined at an angle 0 with each other. Implies that R equal to root over P square plus Q square plus 2PQ. Cos 0 means 1. Cos 0, that is 1. So P square plus Q square plus 2PQ in the sense P plus Q whole square. That is R equal to root over P plus Q whole square. That is P plus Q whole square and root means square and root cancel each other, implies that P plus Q. That is P plus Q. So R equal to P plus Q, implies that P means mod P bar plus Q means mod Q bar. Okay, resultant equal P plus Q, that is mod P bar plus mod Q bar. Simply in this case, vector addition becomes equal to algebraical addition. Algebraical addition in this case, especially when theta equal to 0 degrees. Okay. Here, for theta equal to 0 degrees, cos theta has maximum value. Implies that this, especially this resultant is maximum resultant. Maximum resultant. Okay. Why it is maximum? Why? Because cos 0 is 1. That is maximum for cosine function. Implies that R becomes R maximum. That is P plus Q. So when the given vectors are parallel to each other, then resultant is maximum. Okay. Now, in second expression, 2 implies that is tan alpha equal to Q sin theta by P plus Q cos theta. That is Q sin theta. Theta means angle between parent vector. That is Q sin 0 by P plus Q cos 0. P plus Q cos 0. Sin 0. Sin 0 in the sense 1. 0. That is 0 by something. That is 0. So alpha equal to 0. Alpha 0 in the sense angle made by resultant with P bar. Angle made by resultant with P bar. That is alpha also 0. So here theta 0. Your parent vectors are parallel to each other, implies theta 0, implies alpha also 0, angle made by resultant with P bar also 0, means with this orientation, suppose given vectors are parallel to each other, in that case we cannot construct parallelogram while adding them. Okay, we cannot construct parallelogram with two vectors parallel to each other. So in that case, resultant also in the same direction as that of P bar and Q bar. So here P bar also, R bar also parallel to P bar and Q bar in this case. Okay, all the P bar, Q bar and R bar resultant, including P bar, Q bar parent vectors, all are parallel to each other. Okay. Now coming to next case, case 2. If theta is 180, for example. Theta is 180. Means anti-parallel. Given vectors are anti-parallel as an example. Here it is P bar. Here it is P bar. Here it is Q bar. See, these two are anti-parallel to each other. Now what is theta between them? 180 degrees. Now, if these two vectors added as per parallelogram of addition, can we construct a parallelogram with these given vectors which are anti-parallel to each other once again? Means we are unable to construct a parallelogram. Why? Because here theta is, when theta is 0 or 180, we cannot construct parallelogram with the given vectors. Okay. Now from first expression r equal root over p square plus q square plus 2pq cos 180 degrees, this case cos 180. Now cos 180 in the sense minus 1, that is minus 1, that is root over p square plus q square minus 2pq. Minus 2pq means p minus q whole square, p minus q whole square, that is r equal to square root cancel with each other. We left with r equal to p minus q, otherwise q minus q, p minus q, otherwise q minus p. That is difference. That is the reason I am taking difference. Why? Because if p is greater than q, it becomes p minus q. If q is greater than p, it becomes q minus p. Okay. So r equal to, I am taking p difference q. In this case, resultant becomes minimum. Why? Because her cosine function, if theta is 180 degrees, cosine of 180, that is minus 1. In that case, r takes minimum value. That is the reason why I am taking here r minimum. R minimum. Okay, r minimum equal to p difference q, or p minus q, or p q minus p. I am taking p difference q. That is mod p bar difference mod q bar. Resultant always positive. That is the reason why p bar difference q bar. Once again, take one more modulus here. One more modulus. Okay, one more modulus. Now, what about tan alpha? Tan alpha equal to q sin theta. Tan alpha in the sense, what is alpha? Angle made by r bar with one of the parent vectors p bar. That is tan alpha equal to q sin 180, q sin 180 by p plus q cos 180 degrees. 180 degrees. That is sin 180. What is the value of sin 180? Once again 0. Once again 0 by something, that is 0. So here alpha once again 0 means angle made by resultant with p bar is 0. 0. That is, what is the direction of r bar here? What is the direction of r bar? In this case, when given two parent vectors are inclined opposite to each other, in that case resultant takes the direction of that parent vector which has greater magnitude. That is, if p bar is greater than q bar, that is mod p bar is greater than mod q bar, then resultant takes the direction of p bar. Direction of p bar. Otherwise, if mod q bar is greater than mod p bar, then resultant takes the direction of q bar. So resultant in this case takes the direction of that parent vector which has greater magnitude. As an example, mod p bar is greater than mod q bar. In that case, this is the direction of resultant. This is the direction of resultant. Okay. So this is what case 2. Case 2. What is that? What is that case? If theta is 180 with each other. Theta is 180 with each other. Now coming to third case. Third case. Before that, what is the reference here? For given two vectors, if we change angle between those two vectors from 0 to 180 degrees, okay, for 0 degrees means if given vectors are parallel to each other, we can get the maximum result. The same given vectors are anti-parallel to with each other, then we can get minimum resultant. Minimum resultant. Okay. So this is the minimum resultant for given pair of parent vectors. Okay. Now coming to some other angle, that is 180 degrees. Given vectors are 180 with each other as an example. 180 over, now perpendicular to each other. 90 degrees. Given vectors are inclined at an angle 90 with each other. At an angle 90 with each other. Right. Now this is the p bar as an example. This is the q bar, p bar, q bar. Now this in this case we can construct give a parallelogram with the given vectors. Why? Because here theta is other than 0 or 180. So we are able to construct a parallelogram. Okay. Now these two are taken as the adjacent sides of parallelogram drawn from the same point. Now take the other two sides parallel to this one. One side parallel to this one. One side. Now diagonal drawn from the same common point is the resultant of these two vectors. So r bar equal to P bar plus Q bar. R bar equal to P bar plus Q bar. Okay. Now what is the angle between parent vectors? That is 90 degrees. So theta is 90 degrees. Now coming to expression number 1. What is the magnitude of resultant? That is root over P square plus Q square plus 2PQ cos. What is the angle now? 90 degrees. Theta is 90 degrees. Sorry, this is 90 degrees. 90 degrees. Here 90 degrees. Now cos 90. What is cos 90? 0. Cos 90, that is 0. So 2PQ into 0. 0. We left with root over P square plus Q square. We left with root over P square plus Q square. Okay. Root over P square plus Q square. Definitely this resultant, this value of resultant lies between R maximum and R minimum. Okay, R maximum and R minimum. Now coming to second expression, tan alpha equal to Q sin theta by P plus Q cos theta. Q sin 90 by 2 implies tan alpha equal to Q sin, what is theta now? Angle between parent vectors 90. Q sin theta by P plus Q cos theta. P plus Q cos theta, theta means 90 degrees. That is tan alpha equal to Q into sin 90 1 divided by P plus Q into cos 90 0. So tan alpha equal to Q by P. Alpha equal to tan inverse Q by P. This is the angle made by resultant with one of the parent vectors, that is P bar. This is what? This angle. This angle, that is alpha. From here to there, angle made by R bar with P bar. That is tan inverse Q by P. Okay. Now what is the inference? For a given pair of vectors, if we add both vectors with 0 is the angle between them, then we can have maximum resultant. For the same given pair of vectors, if we add both the given vectors with 180 degrees with each other, then we can have minimum resultant. For remaining all angles, that is between 0 to 180 degrees, we can have intermediate values. Intermediate values. Now, what is the inference? What is the inference here? Inference. What is the reference point? That is R maximum less than or equal to R less than or equal to R minimum. R minimum. So R maximum less than or equal to R. Sorry, greater than or equal to R maximum greater than or equal to R greater than or equal to R minimum. What is R maximum? That is P plus Q. What is R minimum? That is P difference Q. P difference Q. P difference Q. That is mod P bar difference mod Q bar with one more modulus. So if I replace P plus Q greater than or equal to R greater than or equal to mod P bar difference mod Q bar, once again modulus. So this is the inference. Resultant cannot exceed P plus Q. Resultant of two given parent vectors cannot exceed P plus Q. At the same time, resultant never be less than P difference Q. Always lies between P plus Q and P difference Q. That is the inference. So one can have different resultant values for the given pair of vectors with change of angle between those two vectors. Right? Now coming to next point. Suppose R bar equal to P bar plus Q bar and mod P bar equal to mod Q bar. Find the magnitude of resultant. You see, you can have R bar, that is resultant vector, by adding two vectors P bar plus Q bar. So P bar plus Q bar gives R bar. In that case, from data mod P bar equal mod Q bar means given parent vectors are of same magnitude. Both are added, then find the magnitude of resultant. Now see, from data mod P bar equal to mod Q bar implies P equal to Q. Implies P equal to Q. Now from first expression, one implies R equal to root over P square plus Q square plus 2PQ cos theta. In this expression, P means mod P bar, Q means mod Q bar, theta means angle between parent vectors. Now R is the magnitude of the resultant, mod R. So here, replace Q with P, otherwise P with Q. Why? Because both P and Q are same. So therefore R equal to root over P and Q both one and the same from data. So replace Q with P, otherwise P with Q. I am replacing Q with P, that is P square plus, once again Q means P only, that is P square plus 2 into P into Q means once again P into cos theta. That is R equal to square root of P square plus P square, 2P square plus 2 into P into P, 2P square cos theta. That is R equal to, here 2P square kept common, that is 2P square into 1 plus cos theta. 1 plus cos theta. 1 plus cos theta in the sense 2 cos square theta by 2. That is R equal to root over 2P square into 1 plus cos theta, once again 2 cos square theta by 2. 2 cos square theta by 2. 2 into 2, 4 under root means that is R equal to 2 2 is 4 under root, that is 2. P square under root, that is P. Cos square theta by 2 under root, that is cos theta by 2. Cos theta by 2. So here P in the sense Q only. This also can be written as a 2Q cos theta by 2. 2Q cos theta by 2. So this is the magnitude of resultant. What is that? R equal to 2P cos theta by 2, otherwise 2Q cos theta by 2. In which case, when parent vectors mod P bar is equal to mod Q bar, in that case, the magnitude of resultant is given by 2P cos theta by 2 or 2Q cos theta by 2. Right? Okay. In this case, when given parent vectors are of same magnitude, we no need to consider this expression. We can have direct expression R equal to 2P cos theta by 2, otherwise 2Q cos theta by 2. Okay. This is a shortcut for getting magnitude of resultant in that case. In which case, mod P bar equal to mod Q bar. Okay. No need to come from the first step. We can have direct step that is R equal to 2P cos theta by 2 or 2Q cos theta by 2. In that case, mod P bar equal to mod Q bar. In this case, coming to tan alpha, Q sin theta by P plus Q cos theta. Coming to tan alpha. So what is the resultant here? Here resultant equal R equal to 2P cos theta by 2, that also equal to Q cos theta by 2. This is the resultant, especially in this case when both are of same magnitude. Coming to second expression, 2 implies, this is what 1 implies. Now here 2 implies, that is tan alpha equal to Q sin theta by P plus Q cos theta. Once again, Q means P only. Replace Q, parentic P, that is tan alpha equal to, Q means once again P only, P sin theta by P plus, once again Q means P only, P cos theta. That is P sin theta by P common here 1 plus cos theta. So P gets cancelled. This can be written as sin theta can be written as sin 2 theta by 2. Sin 2 into theta by 2. 2 gets cancelled, we left with sin theta only. So this can be written as P gets cancelled, sin theta, sin 2 into theta by 2 by 1 plus cos theta, 2 cos square theta by cos square theta by 2. That is tan alpha equal to sin 2a form. Sin 2a, a means theta by 2. Sin 2a means 2 sin a cos a. That is 2 sin a means theta by 2. Cos a, cos theta by 2 whole divided by 2 cos square theta by 2. Cos square theta by 2. So cos theta by 2, cos square theta by 2 gets cancelled. We left with 2 into sin theta by 2 by cos theta by 2. That is 2 tan theta by 2. So tan alpha equal to 2 tan theta by 2 in this case. Okay. Next, one more numerical. Suppose R bar equal to P bar plus Q bar and R max divided by R minimum equal to 3:1, that is 3 by 1. Find the relation between P and Q. See, two parent vectors P bar and Q bar collectively gives R bar. That is R bar equal to P bar plus Q bar. Moreover, from data, maximum resultant divided by minimum resultant, that is 3:1, 3 by 1. That is maximum resultant is 3 times minimum resultant. Then find the relation between mod P bar and mod Q bar. P means mod P bar, Q means mod Q bar. Okay. Now see how to solve this sum. R max by R minimum. That is R max by R minimum. That is equal to 3:1. 3 by 1. What is R max for P bar and Q bar? For given parent vectors P bar and Q bar, R max in the sense now only I have written, that is R max means P plus Q, R minimum means P difference Q. So R max P plus Q for given parent vectors P plus Q by R minimum. It may be P minus Q, otherwise Q minus P. If P is greater than Q, P minus Q. If Q is greater than P, Q minus P. I am taking P is greater than Q. That is the reason why I am taking P minus Q. So R max by R minimum equal to 3 by 1. 3 by 1. Now take cross multiplication, P plus Q into 1 equal to 3 into P minus Q. That is P plus Q equal to 3P minus 3Q. Okay. Q minus 3Q. Take this side, that is 4Q equal to 3P minus P, that is 2P. So 2Q equal to P. This is the relation between P and Q. This is the relation between P and Q. So whenever ratio of R max to R minimum given, you have to consider P plus Q by P minus Q. Okay. Next, one more numerical, that is the resultant of two forces P and root 2P is root 10P. The resultant of two forces 2P and root 2P is root 10P. Then find the angle between forces. the resultant of two forces. What are the given forces here? Parent vectors. One is of magnitude 2p, other one is of magnitude root 2p. Their resultant of magnitude is root 10p. Now the question is to find angle between parent forces. What is angle between 2p and root 2p? That is the question. Now see here p bar, here q bar, here r bar. See, this is of magnitude p bar, this is of magnitude q bar, this is of magnitude r bar. Now theta is unknown. See this expression number 1. Resultant, the magnitude of resultant r equal root over p square plus q square plus 2pq cos theta. Here p means 2p, q means root 2p, r means 10p. Here say 2p root 2p root 10p. This is what p. From our notation, that is number equation number 1. P means 2p, q means root 2p. This is what q. Now this is what resulted, that is r. Now one implies on squaring both sides. See, one implies on squaring both sides, r square equal to p square plus q square plus 2pq cos theta. 2pq cos theta. Okay, on squaring equation number 1 on both sides. We will have r square equal to p square plus q square plus 2pq cos theta. Okay, 2pq cos theta. Now r square in the sense root 10p whole square, that is 10p square. P square in the sense 2p whole square, that is 4p square, plus q square in the sense root 2p whole square, that is 2p square, plus 2 into p means what? 2p. Q means what? Root 2p. 2pq cos theta. Okay. Now see 10p square equal to 4p square plus 2p square, that is 6p square, plus 2 2 ja 4, 2 2 ja 4, 4 root 2, 4 root 2, 2 2 ja 4, 4 root 2 p into p square cos theta. Now see 10p square minus 6p square, that is 4p square equal to 4 root 2p square cos theta. So 10p square minus 6p square, that is 4p square equal to 4 root 2p square cos theta. That is 4p square common. We left with 1 equal to here 1. We left with 1 1. Why? Because 4p square cancel with each other. So 1 equal to root 2 cos theta. So 1 by root 2 cos theta equal to 1 by root 2. Cos theta equal to 1 by root 2 implies theta equal to 45 degrees. 45 degrees. Okay. Theta equal to 45 degrees. So when the resultant of two forces 2p and root 2p is root 10p, what is the angle between forces means theta equal to 45 degrees. Okay. Now, here we have, next sum we have two set of forces, say 2 Newton, 4 Newton and 5 Newton, number 1. Number 2, 2 Newton, 4 Newton, 8 Newton. These are the given set of forces. In first set we have 3 forces, 2 Newton, 4 Newton, 5 Newton. In second set we have one more 3 forces, that is 2 Newton, 4 Newton, 8 Newton. Do they keep particle in equilibrium? Suppose these 3 forces, see first set these 3 forces, 2 Newton, 4 Newton, 5 Newton acting on a particle simultaneously. Will they keep that particle in equilibrium? That is the question. Similarly, in second case, 2 Newton, 4 Newton, 8 Newton also acting on some other particle to keep that particle in equilibrium. Is it possible for this set of forces to keep that particle in equilibrium? Let us see. That is the question. Now, coming to first question, that is 2 Newton 4 Newton, 5 Newton. See, here we have three forces in that set. Among all these forces, that greatest value, that is 5 Newton, is to be taken as the resultant. See, this is the resultant. This is the resultant. Other two are parent vector, that is P, this is what, Q. See, in this set, maximum value is to be taken as resultant. Other two are parent vectors, to be taken as parent vectors. Okay, parent vectors. Now, what is the maximum resultant? P plus Q. What is the minimum resultant? P difference Q. Now, say R max. R max equal to P plus Q. P plus Q in the sense 2 Newton plus 4 Newton. That is 2 plus 4. That is 6 Newton. 6 Newton. Now, what about R minimum? R minimum equal to P difference Q. P difference Q. P means 2 Newton. Difference Q means 4 Newton. 2 difference 4 means that is 2 only. Why? Because 4 minus 2. That is larger minus smaller. That is 2 Newton. Now see, for these two parent vectors, as per the angle, as per the taken angle, once theta is 0, in that case 6 Newton, one more time theta equal to 180 degrees, in that case resultant is 2 Newton. Okay. When these two forces are inclined parallel to each other, resultant is 6 Newton. If these two forces, parent forces, are inclined at an angle 180 with each other, in that case resultant is 2. Now see, given max value is to be taken as a resultant, no, that resultant lies between these two or not? Check once. See, 5 lies between 2 and 6. 5 lies between 2 and 6. See, 2 Newton, 3 Newton, 4 Newton, 5 Newton, 6 Newton, that's like that. So as per the given angle between these two parent vectors, parent forces, we can have all these values as per the given angle. Among those, this is the R minimum. This is the R maximum. So our resultant, what is our resultant for these two given parent vectors? As per given theta, 5 Newton, is it possible or not? See, yes, 5 Newton can exist between 2 Newton and 6 Newton. Why? Because 5 lies between 2 and 6. Therefore, this force resultant can exist between these two. So that is the reason why first set of forces can keep that particle in equilibrium. Yes, set 1 can keep particle in equilibrium. Okay, so because the first set of forces, that particle can exist in equilibrium. Okay, coming to second set, let us see second set. 2 Newton, 4 Newton and 8 Newton here. 8 Newton. So among these three forces, 8 is maximum. That is the reason I am taking 8 as resultant, other 2 as parent vectors. Once again, R maximum P plus Q, that is 2 plus 4, 6. R minimum 2 difference 4, that is 2 Newton. Now see, R minimum 2 Newton, R maximum 6 Newton, but given 8 Newton exceeding this R maximum. Why? Because between 2 and 6, 8 cannot exist. 8 Newton cannot exist between 2 Newton and 6 Newton. What is the position of 8 means? Beyond 6. Okay, we can't get 8 with these two parent vectors. Why? Because maximum resultant itself 2 plus 4, that is 6 1. That is 6 1. But here, among three forces, 8 is given. We can't get 8 by adding these two parent vectors. 2 plus 4, max value 6 only. But given resultant is 8. That is the reason why this second set, making use of second set, we can't keep the particle in equilibrium. Cannot. Set 2 cannot keep the particle in equilibrium. Why? Because that 8 exceeding maximum resultant. What is the maximum resultant? 6 1. 6 Newton itself maximum resultant. But in the set 8 is the given maximum value, which is not possible to have 8 between 2 and 6. That is the reason why, especially second set of forces cannot keep the particle in equilibrium. Okay. one more sum, that is, here we have three vectors on circle. Say this is what OA from center, this is what OB from the same center, this is what OC, right? Here we have three vectors drawing from the center of the circle, okay, onto circumference, OA bar, OB bar, OC bar. Now what is the magnitude of each vector R1? From here to there R, from here to there R, from here to there R. So R is the radius of that circle, in fact, radius of that circle. Okay, now what is the angle made by OB bar with x-axis here, that is 45 degrees. Now the question is, find mod OA bar plus OC bar plus OB bar. Find the value of magnitude of resultant of all these three vectors. All these three vectors. See, OA bar plus OB bar plus OC bar, we can have one vector. Find the magnitude of that resultant vector. Let us see. OA bar in the sense, OA bar equal to, see, the direction of OA bar, that is x-axis. How to get vector? By multiplication of its magnitude with direction. See, what is the magnitude of each vector R1? R. What is the direction of OA bar? That is x-axis. So what is the x-axis? X-axis in the sense, what is the unit vector along x means? That is I cap, R I cap. Coming to OC bar. What is the magnitude of OC bar? Once again R1. Once again R into, what is the direction of OC bar? That is positive axis. What is the unit vector along positive axis? That is j cap, R j cap. So how to get the vector means magnitude multiplied by direction. Here magnitude R into I cap, here R into j cap. That's all. Now coming to OB bar. OB bar in the sense, see, OB bar is in xy plane. In fact, OA bar is along x-axis, OC bar is along y-axis, but OB bar is in xy plane. That is, it can resolve into components. That is, hypotenuse, that is R. Here what is the component? X component R cos 45. R cos 45 into I cap plus, what is the opposite side? R sin 45. R sin 45 into j cap. See once again, OB bar in the sense, x component into I cap plus y component into j cap. See, x component means this intersection, y component in the sense this intersection. This is x, this is y. X means Rx means R cos 45 into I cap plus, this is what opposite side, R sin 45 into j cap. R sin 45 into j cap. Alright, that is OB bar equal to R cos 45 means 1 by root 2, that is R into cos 45, 1 by root 2, that is R by root 2 into I cap plus R into sin 45 also 1 by root 2, that is by root 2 into j cap. This is what OB bar. OA bar, OC bar, OB bar. Now take OA bar plus OC bar plus OB bar. OA bar plus OC bar plus OB bar is equal to, OA bar means RI cap plus OC bar means R J cap plus OB bar means R by root 2 into I cap plus R by root 2 into J. Now see here, RI cap, here R by root 2 I cap. So I cap is common, otherwise R is common, RI cap is common, R into 1 plus 1 by root 2 into I cap plus, here R J cap, R by root 2 J cap. So R is kept common, that is 1 plus 1 by root 2 into J cap. So this is what OA bar plus OC bar plus OB bar. Now take the modulus. We have to find the magnitude of this resultant. This is what resultant vector. In fact, this is what resultant vector. We need to find magnitude of resultant vector. That is mod OA bar plus OC bar plus OB bar equal to root over x square plus y square. That is r into 1 plus 1 by root 2 whole square plus r into 1 plus 1 by root 2 whole square. See, this is x, this is also x square plus x square, 2x square under root. That is 2x square under root. X square plus x square means 2x square under root. Square root cancel. That is 2r into 1 plus 1 by root 2. So, see, I am rubbing somewhere here. See, this is what x, this is what x. Both one and the same. That is x square plus x square, 2x square. This is what x. This is also x. That is mod OA bar plus OC bar plus OB bar is equal to root over x square plus x square, 2x square under root. Root 2 square cancel. We left with root 2 into x. That is root 2 into, once again x means what? r into 1 plus 1 by root 2. That is, take LCM, root 2 plus 1 by root 2. Root 2 cancel. That is r of root 2 plus 1. This is the final resultant. This is what the magnitude of resultant of all these three vectors. That is OA bar plus OB bar plus OC bar. Magnitude of all the three vectors. Okay. What is the ultimate result? R of root 2 plus 1. R of root 2 plus 1. Right. Coming to one more numerical. That is the magnitude of the resultant of two forces. The resultant of two forces, one doubles the other, the other in magnitude is perpendicular to that force having smaller magnitude. See, the resultant of two forces, one doubles the other in magnitude, is perpendicular to that force having smaller magnitude. Then find the angle between the forces. Find the angle between the forces. See here, resultant of two forces. Here we have two parent vectors, means two forces. One double the other in magnitude, means suppose F1, mod F1 bar equal to P, mod F2 bar equal to 2P from data. The magnitude of one force, let it be P. What is the magnitude of other force? 2P. One force doubles the other in magnitude, that is from data. See, the resultant of two forces, one doubles the other in magnitude. One doubles the other in magnitude. Say F1 bar, modulus of F1 bar is P, modulus of F2 bar is 2P from data. And moreover, the resultant of these two forces is perpendicular to that force having smaller magnitude. The resultant of these two forces is perpendicular to smaller magnitude. Which is of smaller magnitude? F1. F1 is of smaller magnitude. Resultant is perpendicular to P. Okay, from data. See, this is what resultant as an example. Resultant is perpendicular to one of the parent vectors. See, a smaller magnitude. I am taking force of smaller magnitude along x-axis. Okay, this is what P. This is what P. Right? This is what P. See, resultant is perpendicular to one of the parent vectors of smaller magnitude. See here, what is the angle made by r bar with one of the parent vectors which is along x-axis? That is alpha. So from data, alpha is 90 degrees. This is what alpha. Alpha is 90 degrees. In fact, what is theta? Theta means angle between parent vectors. One parent vector P, other parent vector 2P. What is the angle between P and 2P means? Definitely greater than 90 degrees. Why? Because alpha itself 90. Now what about theta? Theta means alpha plus beta. That is 90 plus something is theta. Definitely theta is exceeding 90 degrees. That is up to the angle. Okay, up to the angle in the sense definitely other force must be taken in second quadrant. Why? Because alpha itself 90. Alpha plus something, that is theta, must be greater than 90. That is up to the angle. So we need to take other force in second quadrant like that. Second quadrant like that. This is what 2P. See once again, angle made by resultant with P bar. Angle made by resultant with P bar, that is alpha. So from data, resultant is perpendicular to one of the parent vectors of smaller magnitude, that is alpha. Alpha itself 90 degrees from data. What about beta? Alpha plus beta must be equal to theta. So angle made by resultant with other parent vector. Angle made by resultant with other parent vector, that is what? Beta. So here it is beta. Okay. Alpha plus beta becomes equal to theta. Theta. So alpha plus beta becomes equal to theta. That is what? Angle between parent vectors. These two are parent vectors. Okay. Angle made by r bar with one of the parent vector p bar is 90 degrees. That is alpha is 90 from data. This is what beta. If you add alpha and beta, we can have angle between parent vectors. That is the ultimate question here. What is the angle between forces? What is the angle between forces in the sense? What is the angle between P and 2P? That is question. That is ultimate question. Now close the parallelogram. Parallel to this vector, take one side here. Parallel to this vector, take one more side here. Okay, right? Now say, if it is P, this one also P1. If this is 2P, this one also 2P1. Right? Now, from this right angle triangle, we can calculate beta. Say, with respect to beta, this is opposite side, this is hypotenuse. So, sin beta equal to opposite side by hypotenuse. That is P by 2P. That is 1 by 2. So, beta equal to 1 by 2. Sin beta 1 by 2 means beta equal to 30 degrees. 30. Beta 30. Alpha, from data, alpha is from data alpha equal to 90 degrees. Alpha 90. Why? Because resultant is making an angle 90 with force of smaller magnitude. That is alpha is 90 degrees. So alpha 90, beta, here we have 30 degrees. Alpha plus beta is theta. So theta equal to alpha plus beta. That is alpha means 90 plus beta means 30. That is theta equal to 120 degrees. Theta equal to 120 degrees. Okay. Once again, if the resultant of two parent vectors, if at all acting right angles to one of the parent vectors, definitely the angle between parent vectors must be greater than 90 degrees. Definitely here the angle between parent vectors is up to its angle. Up to its angle, that is 120 degrees in this case. In this case, especially 120 degrees. Okay. Okay, friends. Please don't forget pressing bell icon so that to receive regular updates. Once again, all of you requesting to please share my videos, comment on videos, okay, like my videos. Okay, thank you. In coming class, we'll discuss subtraction of vectors. Okay, friends, thank you.